Okay, we are going to quickly go through a revision of the gases, ideal gases and thermal properties chapter, pages 175 to 208. The motion of particles, kinetic theory of gases. Please go back to page 176 to 177, that is revision from grade 10. Real gases versus ideal gases. Now, a real gas is an actual gas that we find every day. Ideal gases is really an ideal picture of a gas. Right, a table comparing these two. Please go through this in detail, and you need to know this table where you will see that ideal gases do not really exist. They have specific properties compared to real gases, and they are very important. I suggest you maybe pause the video here and take down this table and make sure that you know it. Then at low temperatures, that is our deviation section on the temperature scale, real gases liquefy. And under normal conditions, for example, STP, standard temperature and pressure, same behavior applies for ideal and real gases. Also at high temperatures and low pressures, also moderate temperatures and moderate pressures. That is where ideal gases and real gases behave in the same way. Temperature, volume, and pressure. This is a brief introduction of definitions and how it applies to this work. Temperature is a measure of the average kinetic energy of particles. The unit, Celsius or in Kelvin. Up to now you worked in Celsius, but in all calculations in this chapter it must be converted to Kelvin. Please remember that we work with average kinetic energy since not all molecules have the same energy. So we need to calculate an average kinetic energy. In fact, you will not have to calculate it. It is just assumed that we work with average kinetic energy. Temperature is directly proportional to the average kinetic energy of the particles. Volume is the amount of three-dimensional space occupied by matter. Units, always cubic units. Pressure, the force exerted per unit area, which is P equal to F over A divided by A, and the unit Newton per meter squared, because it is force divided by square meters, and that is the same as a Pascal. Then absolute temperature. Theoretically, it's the lowest temperature where no movement of particles is possible. Absolute temperature is the temperature measured from absolute zero in Kelvin. Now, these two definitions are easily confused. Please make sure that you understand what absolute zero is, that it is the absolute lowest point, and absolute temperature is the scale on which we measure from Kelvin, in Kelvin from zero. Then the Kelvin scale calculated like that from Celsius, and we must be able to convert from Kelvin to Celsius as well. Then the graph on page 184. Please look at this graph. It is about the extrapolating of the graph in order to find the absolute zero on the bottom axis, the horizontal axis. Then a quick mathematical background. Straight lines, remember that it's y directly proportional to x, your y equal to mx plus c. And that is your direct proportionality, where m is a proportionality constant, and we called it gradient in mathematics, or the constant factor that x is multiplied with to get y. The hyperbola is your inverse proportionality. K again is the gradient of the graph, y versus 1 over x, and it's again a proportionality constant. Then the three gas laws. First one, Boyle's law, fixed volume of gas, and in this one, please, the temperature is kept constant and the relationship between pressure and volume is shown, where P is directly proportional to 1 over V, or in other words, inversely proportional to V, or volume. How do we explain this? The volume decreases, therefore there are more frequent collisions with the sides of the container per unit volume of gas molecules. The gas laws continues now with Charles's law. In this one, the constant pressure and the volume is directly proportional to the absolute temperature. In mathematical format, looks like that, V directly proportional to T. Then the Gay-Lussac's law. In this one, the constant volume and the pressure is directly proportional to absolute temperature, where in mathematical terms, P directly proportional to T and another proportionality constant of K. Please remember, in all three laws, there's a constant amount of gas, a fixed amount of gas. Then the general gas equation. Remember that PV equals nRT. R equals 8,31. That is called the universal gas constant, where R will now be the proportionality constant. Very important that you remember the units are different in the general gas equation, and that is where we sang it. So let's sing it. Pressure in Pascal, volume in meters cubed, temperature in Kelvin. And you need to remember this. It is very important. Also, then all examples on P1 V1 over T1, P2 V2 over T2. Only temperature you need to convert to Kelvin. The other units for pressure and volume can be in any unit, just as long as it is the same on both sides of the equation. But temperature in the denominator needs to be in Kelvin always. Then there's a short section on the number of molecules versus kinetic energy of the molecules. Please go back to page 203, study that and do a lot of examples. Now that is all for today.